So now we'll discuss the derivation of AC curve with the help of AFC and ABC curves. So we know that in the short run, TC equals total cost equals to total variable cost plus total fixed cost. So if we divide it by the level of output, so what we will get? Both sides TVC by Y plus TFC by Y. So from here we can write average cost equals to average variable cost plus average fixed cost. So from this we can say that at any level of output, the average cost will be the sum of the average variable cost and average fixed cost at that level of output. So that means we can easily draw the total average cost curve with the help of the vertical summation of these two curves, average variable cost curve and average fixed cost curve. Now let's explain it graphically. So in this diagram we measure output in the horizontal axis and cost in the vertical axis. So now this is our average fixed cost curve, AFC, and this is our average variable cost curve, AVC. So if we consider that the output level is OY1, so at OY1, what you see here, the Y1 F1 is the average variable cost, and Y1 F1 is the average fixed cost, and Y1 V1 is the average variable cost. So what will be the average fixed cost at this level? So we can see if Y equals to OY1. Okay, if Y equals to OY1, AVC equals to Y1 V1 and AFC will be equals to Y1 F1. So what will be the AC? AC will be definitely the sum of Y1 V1 plus Y1 F1. So what we have to do here? We have to take the value, that measure the value Y1 F1, and above we have to add this value. So in this case, if we see that this is the Y1 C1, so definitely if we see that Y1 C1, so here we have to write that this segment C1 V1 must be equal to Y1 F1. So we are plotting the distance above and we will get the value of average cost, that is Y1 C1. So similarly, if we take another point, whenever output level is OY2, so average fixed cost is declining. So average variable cost is also declining. So this is Y2 F2 and this is Y2 V2. So from first feature of y1 c1 is that y1 c1 equals to y1 v1 plus c1 v1, which is nothing but y1 f1. So similarly at this point, that if we have to plot the same distance again, and this distance must be that v2 c2 must be equal to y2 f2. So each and every level of output, if we want to find out what is the value of average cost, we have to make the vertical summation of these two different values. That means for y3 it is y3 f3, y3 v3, so this will be the average cost. So y3 v3, y3 c3 will be the average cost. So one thing is clear, that as the output level increases, average fixed cost will decline. So the vertical distance between average variable cost and average cost curve, this will decline. So average cost curve will be also initially downward sloping. Next thing is that whether it will be increasing or diminishing. So up to this output level OY4, we find that both AVC and AFC are declining. So as the AC is the sum of AVC and AFC and both are declining, it is clear that AC will decline. Average cost will decline up to the output level OY4. But after OY4, what happens? The AVC starts to increase, but AFC is still declining. So the value of AVC is increasing, but value of AFC is decreasing. So whether the AC will rise or fall, it will depend upon the relative strength of these two. That means if we see that here after this point, rate of rise in AVC is less than rate of fall in AFC, the total average cost will still decline. So initially what we see, after this point, the rate of decline in AFC is greater than the rate of decline in AVC. So AC continues to fall. But after some time, what we will find, the rate of decline in AFC is exactly equal to rate of increase in AVC. That means AC will stop falling. So AC will reach its minimum point. And after that, what we see, the rate of increase in AVC is greater than the rate of decline in AFC. So definitely the average cost will start to increase. So one thing is clear, that the vertical distance between AVC and AC will be declining as the level of output increases. Because as the level of output increases, average fixed cost is declining, and we know that the difference between average variable cost and average cost is the average fixed cost. So at any level of output, the vertical distance between AC and AVC curves will be exactly equal to the vertical distance between AFC curve and horizontal axis at that point. So what we can find, that as AFC is declining, the distance between AC and AVC will gradually declining. Next thing is that whenever the average variable, the level of output at which average variable cost is minimum is less than the level of output at which the average cost is minimum. So this is the basically derivation of AC curve with the help of AFC, average fixed cost curve, and average variable cost curve. So average cost curve is also U-shaped, but the minimum point of average cost curve will always be at the right side of the minimum point of the average variable cost curve. And as AFC will converge towards the horizontal axis, but it will never intersect the horizontal axis. Similarly, AC will always converge towards the AVC curve, but AC and AVC will never intersect will never intersect each other. The distance between, vertical distance between these two will be definitely declining, but they will never intersect each other because AFC is always greater than 0. So this is the derivation of average cost curve with the by the vertical summation of average fixed cost and average variable cost curves.